This is a very interesting case study where we are going to compare two texts. Now, a text can contain a string of words, and that's what we want to compare. But definitely, it's going to be much more interesting than that. So, I hope everybody is aware of Quora, but if you don't know it, it is very similar to the platform like Stack Overflow. So in your Stack Overflow platform, you can anytime go and there you can write any of your technical question and people are going to respond to that technical question. And then any other user or you yourself can go and upvote or downvote that particular answer. Similarly, Quora is one of the platform where a user can go and type any generic question and they can get their responses. So let me show you how it looks like. The platform looks something like this. If you see here, you can have any type of questions coming here, like what are some unwritten social rules everybody should know. If you click on more, you can even kind of read some very interesting responses, what people do write with respect to images. Right? So that is very interesting answers what you can read. If you like it, you can always go ahead and just upvote this, or if you don't like it, you can anytime go and downvote. So you can see the support option, there's a share option, you can downvote it, even you can report it and so on. So all these things are available. If you want to ask any question, you can always click on add questions and you can always ask a particular questions here. And this is a very famous platform. In fact, I myself use this a lot. So I kind of prefer to kind of keep reading a lot of question answers. It's an unlimited kind of resource for you to get a lot of knowledge about anything and kind of hear up the other point of view on any particular topic. Now, but since this platform is quite famous, definitely there will be few of the things which require a good solution. For example, maybe I can write a question which is already kind of being asked by somebody else, right? But there is a catch here. Maybe my wording and that question wording is little different. Okay, that's where is the catch. Now, there is a possibility if it is exactly similar words, I can simply say that okay, these two questions are duplicate, but that's not the case here. In fact, the case here is that I don't really know that what is going to be the sequence of what. Maybe somebody can write the same thing in a very different way and I can ask the same thing in a very different way. Now, what the problem statement here is that Quora want to identify two very similar questions so that once they notice these questions which are very similar, they can kind of mark it as duplicate and they can a person who have asked question 2, let's say who have asked later, so all the answers from it he will be able to immediately view it here, right? So if that happens, so at least the user who have asked the question, he need not go and search here and there. So he will be simply able to come and read the answer. So I want to kind of create a connections maybe between both the questions, which I am finding it as duplicate. In fact, this is one of the solution. This is one of the solution the Quora is already using in it. Because if you are a Quora user, you might have noticed a lot of many times that they do kind of mention that okay, this is duplicate, or you post a question, after some time you get that notification and then they start showing you that answer. So they are using it, but at the same time, what they have done, they have made this topic available on Kaggle for everyone. They have made it kind of open for everyone so that any user who wants to come and can provide a good solution, they can go ahead and do it. Now let me show you how you can view all of that. So you have to come here. I have already given you a link here. You can just click on this link. It will take you to the Kaggle page. Now here you can see that it is awarded with $25,000 kind of money if you are able to win this particular competition, and you can always go and kind of basically you can go ahead and try to explore this particular problem. It is very interesting, guys. It's very interesting. In fact, you will find a very real data set what Quora have provided to us, and you can just go ahead and look at the data set and try to understand and kind of try to solve it. In fact, I would strongly recommend you, after solving so many case studies, you can definitely attempt this question on your own, and if it do not come up, definitely you can have your solution for it. Now here also there is a evaluation metric. Like you can see here, you also have a log loss which you need to basically load up. You also have your data. So here again, log loss we have already learned in my last case studies as well. Data, if you want to download, you can anytime go here and can download, let's say this train.csv. This too includes a lot of data for you. So you can go ahead and download and can start using it. If you want to download it, one way to do that is you can just type this particular command and it will help you to download. But you can, when you will directly type it, it will give you an error that Kaggle is not found, right? So you need to go to this particular link to get the Kaggle API. The whole description is there. You can always go ahead and install Kaggle APIs, and then when you will do it, the data set will come to you. On the other hand, since this data was not very huge, so we are also going to upload this data for you on the portal. So you can anytime download it directly from there as well. It's up to you how you want to do it. So let's start working on this interesting problem from next video lecture. Okay, so after we understood the problem, let's go ahead and start working on this data set. So first we need to import all these packages because these will be definitely required for you. After that, we are going to load this train.csv file, which includes all the data set provided by Cura. Now, if you look at the shape of the data set, we do have some 404 290 number of rows present, and there are 6 columns which are present. So we will understand what are those 6 columns. Then further to this, we can just describe just to understand that how many of the values are present here. And we can also do a quick information check by looking at what is the type, how many values are present, and so on. One interesting thing you can note here, that there are definitely some missing values, right? You can see here that we do have like 2 missing values in question 2, because looks like total number of values is 290, here we have 288, and looks like there is also something catchy here, 289, right? So we may want to deal with missing values in this case. So this is one of the good information what we can capture from here. Now we can look at the number of columns present in this. So we can always see columns, and we can see ID, QID 1, and so on. Let's understand what is this columns. ID is your definitely row ID, which we can always mention it up. Second thing is you can find second thing here as QID. QID means any unique ID for your questions. For example, in this case, I have QID 1, QID 2, means there will be 2 questions which I am going to compare. Both will be unique questions, and I am going to compare these 2 questions which belongs to this ID. Third one is what is that question 1, right? What is the text present in that question 1? Question 2, what is the text present in my question 2? And then there is a is duplicate. If the value of is duplicate is 0, that means the question is not a duplicate. If the value is 1, that means that question is a duplicate. So that's the reason we have defined like this. Now let's see that how the data is going to look like. You can see here that this is the row ID. We do have QID 1, means the question IDs for each. So question ID 2, what is that particular question 1, what is that particular question 2, and then we do have is underscore duplicate. So this is what we can also see from here. Let's see a few of the examples to have a better understanding of this. So you can see here that we do have this sort of data where we have ID, QID 1, QID 2, question 1. But let's see this. So let's say for row ID 0, we do have a question ID 1, question ID 2, and the question is, what is the step-by-step guide to invest in share market in India? Okay, that's the first question. Second question is, what is the step-by-step guide to invest in share market? So the first question is very specific to India, while other question is very much generic. So definitely they are not duplicate questions. So we have to mark it as 0. Now let's look at the second one. What is the story of Kohinoor diamond? What would happen if the Indian government stole the Kohinoor diamond back? Right? Now, if you look at it, again, both the questions are very different. So again, we will mark it as 0. Let's look at the third question, which is not basically, which is going to be similar. How can be a good geologist? What should I do to be a great geologist? But if you look at this question, the wordings is definitely very different, but they both are similar in nature. That's the reason we're gonna put it one value. Similarly, we can also look at another question. How do I read and find my YouTube comment? Second question. How can I see all my YouTube comments? Again, this is similar. So we're gonna mark it as one. So this is how my data looks like. So given any two questions, I want to predict whether it is going to be similar question or non-similar question. That's a problem statement, what we are going to solve. Now let's understand that how this problem is going to translate in machine learning world. So since my output is going to be either 0 or 1, because here we are saying that whether it's a duplicate question or a not duplicate question. So it is definitely a binary classification problem. We have also seen before that from the Kaggle competition that we are looking for a minimum log loss problem. So that's the reason the evaluation metric is going to be a log loss here. And we are also going to look at binary confusion matrix because that's what we normally understand more easily. So that's what we have added extra. Now there are few things to keep in mind while solving this particular problem. If there is any error, imagine that there is a question which is not duplicate and Cura thought it's a duplicate one. Then that error is going to be very costly for Cura, because in that case people will have mistrust on Cura. They might be expecting some answer, but they are getting wrong answers now, right? So they will kind of lose their interest from Cura and people can move away. So the errors are going to be very, very costly for them. So since the error is very costly, maybe it will be a good idea if we talk in terms of probability. Means maybe I want to create something like probabilistic part, like probability that question 1 and question 2 are going to be similar only and only if the probability of their similarity is maybe greater than or equal to 0.99, means 99% or above. If that probability is, then only I'm going to say that these questions are similar. Otherwise it's better to keep them non-similar only. Even if they are similar, let's not touch them up, otherwise it may end up with a lot of other issues. Now, so we can decide that threshold for us. What about time taken? Do you think we need a lot of time to do this, or we have to very quickly return the result? No, means it's okay. We can take some our own sweet time. Definitely, it should not end up taking almost the whole day also. Yeah, but your model is okay to take maybe few minutes to give you the output, and then you can send a notification that yeah, these are duplicate and we are merging this up. So that's something you can always do. So the latency you can have with your own pace. What about interpretability? Do we need interpretability? May not be that important. From at least for the user point of view, it's not important. When Cura is going to mark any question as duplicate, Cura need not inform that user why I'm marking it as duplicate, right? This may be required for their internal part, but definitely they don't need it to show to the particular user. So these are the things you need to keep in mind while solving this binary classification problem. So let's do it from again the next video lecture. So now we are going to look at the distribution of the data. What I mean is that we're gonna give some answers in terms of like how many values are 0 in duplicate column, how many values are 1 in duplicate column, how many unique answers are there, and so on. So we're gonna find out all those answers now. So to start with, we're gonna take up this part where we're gonna write this code just to identify that in my data set how many are 1 and how many are 0. So you can see here that 0 values are much more than your 1. So, and that's basically means that most of the questions are going to be non-similar in nature rather than similar in nature. Now moving ahead, we are also going to figure out the percentage now. So because from this graph you are not able to make out that what's the percentage that the values are 1 and what is the percentage that the values is 0, means what is the percentage of duplication in the data and what is the percentage of non-duplication in the data. So those things we can easily compute, and the value for your similar questions is going to be 36.92%. which means that we're going to have 63.08% of 63.08% of the question which are going to be non-similar in nature. Further to this, we're going to figure out the unique values. What I mean by unique questions here. So let's say I have question 1 and question 2, I have question 1, question 3, I have question 3, question 4. So though there are so many parts, but unique questions are question 1, question 2, question 3 and question 4. So I want to figure out how many unique values are present in this. So I can easily do that again with the help of this particular code, where we can figure out only the unique questions, and my unique question comes out to be some 5,37,933. These are my unique questions what we have in the overall data set. Now further to this, let's answer a few more questions. Like we want to, let's say, figure out that how many unique questions are there which are repeating more than one time. So that code also we can just very quickly write it up, and we got almost 1,11,780 questions which are getting repeated. In terms of percentage also we can look at, that means 20.77% questions are there which are getting repeated. We want to figure out now the question which is repeated almost the maximum number of time. So that also we can get that, and we got 157 as a number which is getting repeated maximum number at a time. Now we will also do few more question answers, but let's do that in the next video lecture. So now let's explore a few more in terms of graph, the data distribution. So here what I'm going to do is, now I'm interested in finding out how many questions are unique questions and how many questions are repeated questions. So you can see that in this case definitely my unique questions are much more in number in comparison to my repeated question. Now after this we want to see that is there any questions of a category where, let's say, I have question 1, question 2 being asked, and maybe question 1 and question 2 again given, means a duplicate question but again in pair. So that is there or not? So we have figured out that no, there is no such type of question which is a duplicate question. If there was such scenarios, we would have to tackle that as well. Then we would have to remove some of the that duplicate data from it. But in this case, we can see that clearly there is no duplication. Then we can also check number of occurrence for each question, and in this case we can also plot a graph for this. So again, this code is quite simple, so I'm not gonna go into each point of code into each project. In fact, in the initial few projects I have already gone through in depth of your code as well. Plus this is all expected that you guys are aware of, so I'm not going to go into depth of each code point. So now here you can see that we do have, there is a question which have occurred 157 times, but if you look at this overall graph, you can notice that most of the questions here are coming like 1, because if you look at this is 1. So most of the questions are just coming once. Then there are few questions that the graph is coming down drastically, right? So you can see that only one of the question is there which is 157 time in number. So this is quite low in number, and remaining maximum of the questions are quite repeating less times, but still this graph is here till this step. So this is how we can evaluate with this graph that the questions are getting repeated how many number of times. Now the next step what we're gonna do is we want to find out the missing value. If you do remember, we were looking at the info command, and from that info command we have seen that there were few questions which were coming out to be nan. So you can see here that this is the nan values are being showing up. Now what we are going to do in this case is, wherever my value is nan, I'm going to replace it with the space. So this is going to be like a missing value, but I'm just representing it in a better way. So that's what we will do. Then once we are done with all this, we have to look at some feature engineering step. Now that is I'm going to explain in the next video, but this is the most crucial part of this particular project. See, analyzing and all that is now quite simple. We have already seen it so many times, but when we have to come to feature engineering, it becomes very important to understand that what are the columns we need to add extra. We can think of them as a derived column. So that we will learn it in the next video. Feature engineering is one of the most critical part of this project, as I said to you in the last lecture as well. Now in this case we are going to derive some of the frequency, and again I would like to thank and credit from a lot of places from where I have myself learned about how to derive all these columns. Now this is an art. Even while solving this project itself, I have learned from various places that how to do all this. there were few new techniques when I came across, and I was taken by surprise. Okay, this is also possible. So definitely whatever I am deriving, maybe there can be much more than that. Okay, so you can always look forward for a few more things. What I'm going to do is I'm going to show you up that how you can think of deriving some new column and how you can judge the importance of those columns as well. Like it's not mandatory that whatever columns you are going to derive, all the columns are going to be the best column, right? It may be possible that they are not. Maybe they are not going to impact your final output of 0 and 1. So in those cases, we would like to ignore those particular columns. So how we can decide on that? So that is what we're going to discuss in this particular lecture. So this is going to be kind of very interesting. In fact, I would call this step as the basic feature engineering. And once we are going to be done with this, I'm going to show you something like advanced feature engineering. Okay. Now that is going to be interesting. That what is basic feature engineering and advanced feature engineering. So we will add some more extra columns which are going to be even more interesting, and you will notice that they will be much more fruitful in terms of giving a response. Let's start with the basic feature engineering right now. So to start with, first column which we are going to derive from here is your frequency question ID. So this is just to look at how many question ID ones are available in my data. Then the same thing is we are going to look at frequency of question ID 2. What is the length of question 1? Okay, so what is the length of total question 1 and the length of question 2? That can be basically another derived metric. Q1 n word means number of words in question 1. This is different from this length. Okay, length means total length by word, character by character. But when I say Q1 n word, it means I'm talking about words. Okay, so not character but number of words present in question 1. Similarly, we can also derive number of words present in your question 2. Once we are done, now this is going to be interesting. We have something called as word common. Now, what does this mean? That we are going to derive a column which is going to just find out the common unique words present in question 1 and question 2. You can think of it just like intersection of common words between Q1 and Q2. Then word total is just going to sum up your words in question 1 and question 2. You can think of it like a union of question 1 and question 2. Word share, this is interesting. In fact, when I will show you up that when you will analyze this, this is going to be one of the important factor for basically deriving 1 or 0. This is going to be interesting. So here you can notice that what we are doing, we are basically word share is going to be word common divided by word total. You can think of it like what we are doing in this case is Q1 question intersection of Q2 question. Basically it's going to be common words, and then Q1 union Q2, though it is not exactly same to be frank, but this is basically something around that what we are calculating in this word share. So we are basically getting the basically the average of what is going to be the common words divided by total number of words what is being present in question 1 and question 2. So that's going to be interesting. Now then after that we are just adding up the frequency of question 1 and question 2. So this is another column, and we are also adding a column with frequency of question 1 with minus subtraction with question 2. Now these are the columns we have derived. Again, this is not going to be the end of story. You can always go and look back at lot many other ways to also see and derive different new columns. Now this is just a simple code to achieve that. Okay, so like for example, you want to find you are writing a function to find the total number of words present in it, right? So this is very simple. What you are using the set method to get the unique values, and then you are just basically adding them up. So this is just a very simple code. You can walk through it. Very simple Python code, and this code is just going to help you to add all these new columns which we have discussed. Now once you have added that, you can notice that all these columns came as a part of my data set itself. So you can see here that now it is adding up frequency QID, frequency QID2, what is the length of Q1, Q2 length, number of words present in Q1 and Q2. We have how many common words present, how many total number of words are present, and you can notice that we do have something called as word share. We are looking at the frequency of question 1 plus question 2 and frequency of question 1 minus question 2. So these are the columns what we were also deriving above, and that's what you can see in the data set. So we have added all these extra columns. Now what we want to do, we want to understand that what is the significance of all these columns. So as I was telling you before, word share was one of the very interesting column which we have got. So I'm going to discuss about that column, that why I'm saying that this came out to be good. So what we have done is we have drawn two plots for this to understand this particular part. And you can see that this is on the, if you look at this right hand side part, my word share, this is going to on the x-axis, and basically this plot we are looking at, if it is, let's say, going to be red color, that means they have a similarity. If it is blue color, they don't have a similarity, like that. One interesting thing, if you note here in this particular graph, we are getting a graph where we have some sort of overlap coming, right? It is coming like this. So if you recall from your EDA analysis what you can basically perform, definitely the best graph could have been that if you would have somehow got with the word share, that as and when my, let's say, this is somehow I got the graph. So let's say this belongs to 0 and this belongs to 1. Then I could have very easily said that, okay, if my word share is lesser than this, I could have written logic. If my word share is less than this, then all the values are 0. That means the similarity is not there. If it is greater than this, then basically there is a similarity is there. But that's the ideal case scenario, which is not going to happen in this case, definitely. So in this case, we do have some sort of overlap coming up. So it is not the best, but it is not the worst also. So you can notice that if my word share is increasing, definitely in that case, I'm noticing more of the points getting into similar zone, right? And on the left hand side, you can see that if the word share is less, then most of the points are falling into my zeroth zone, right? So this is an interesting fact what we can get from it. And in fact, from here also you can see that this is a volume plot, but if you draw a box plot with it, right? So box plot is going to look something like this. This is going to be a median, and you can see here also, if I draw this box plot, this is a median. So you can see here also, though my box plot is exactly not coming up to be similar, but still my box plot is something like this. So there is a small difference basically here. So this, for word share 1, I do have basically median value to be higher than this. So we are still able to infer something out of it. It's not going to give us the exact inference, but we can still come up with some inferences in this case, and this means that this column was actually coming up to be one of the good column to go ahead with. Now let's look at few more things with respect to this. So this, we understood that word share can be an important factor. Let's do the same kind of working with respect to my word common column, which we have also created. So now in this case, we can notice that when we draw this graph, this do not comes out to be good. So you can notice that this is the worst graph, right? If I have something like one plot is coming like this and the second plot is also coming like this, that means I cannot at all infer anything about from this particular column about for basically something like whether it belongs to 0 or 1. And even if you look at their histogram here as well, my histogram are also kind of very similar. If you look at this, there's no much difference in terms of height of both the histogram medians and all that. So this column is not useful. Now I want to give you as a homework activity to try this for all rest of the columns, though I have done it only for these two, but I would strongly recommend all of you to follow this and see if you can also do this exercise for remaining all of the column. In fact, we have done this and we have not found any other column to be much more useful. So this was a very nice way of figuring out whether a particular column which we have derived is going to be have any meaning or not. But definitely we did got word share, which was quite useful. So let's keep that, and we will see that this is going to be how we're going to use it in the further purpose. So now after we are done with this, we have to also do some processing on the text data, because that text data is huge and we definitely cannot just use it as it is. We have to do some changes in terms of removing some stop words and all that. So we will see to this in the next video, that how to perform all of the text processing. So now let's perform some text pre-processing on this data. So we do have a lot of text, right? Because we have questions, question 1, question 2, which is completely in the form of text. Now text contain words. So definitely we cannot just use it as it is as an input to my machine learning algorithm. Instead, I have to transform it into a format which my machine learning algorithm can understand. Now, in order to do that, we have to follow some steps. Like for example, since Quora is a web page, definitely it's going to have some sort of tags like BR tag, H tag. So we would like to remove them. We can't keep all these tags into my problem, because if you think about it also, it's not going to be any helpful in determining that whether the question is similar or not, right? Because if somebody is saying BR, that means he want to go to new line. If he's saying H, so maybe he want to define a heading, but that have basically no kind of significance in form of when we look at the similarity. So we may want to get rid of it. Second thing is removing the punctuation. So in my problem, I do have semicolons, I have comma, I have dot, right? I have this colon. So I would like to remove all of them also, because again, this is also not going to be any helpful in kind of predicting my final output of whether it's a duplicate or not. Third, this thing you have learned a lot during your NLP part. So I'm not gonna into this. In fact, this is the main thing what we perform in our NLP, doing the stemming, removing the stop words like a and the, right? And we also want to make sure that running, run. So these are the same kind of words, and we want to represent them similar way. So those are the steps also we need to perform. We will also do some contradiction. In fact, this was one of the fun part which basically we learned while solving this problem. If you look at this contraction, what basically it means is, like if you look at the data, like some people have let's say habit of writing let's say 1000, right? So what I will do, I will represent it as 1k. So you can see that I'm just looking at replace. If there is 000, I'm going to represent it as 1k. Similarly, if this is the thing, I'm going to represent it with m, which means million, right? Similarly, if I have basically this sort of stuff, I'm going to replace it with this. So you can see that we have a lot of meaningful kind of conversion which we are doing in this process. So we have like won't, which means that will not. We have cannot, we can replace it with this. So whichever is making sense, like if we do have like she is, right, I am. So we do have a habit of writing like this. So we are kind of physically transforming all these values. Now we also are transforming. Sometime, let's say somebody have written rupee like this. Like this is, if you don't know what is this, this means Indian currency. Now I am representing it like this. Similarly for Europe also we can define it. For percent also we can define it. So like this, what we are doing, we are kind of transforming to a meaningful information. That's what we are basically going to perform into this part, contraction. So this was even this is the beauty about machine learning, that you keep on learning while solving these kind of problems, and you really learn a lot while doing so. So rest of the code is quite simple. We are just performing those steps of, we are using the Potter stemmer. We are going to use all that beautiful soap and all those functions to basically perform all these things what we have just discussed, right? So this is quite simple way using which we can process our text data and can basically come up with some very interesting outputs. Now in the next lecture, we are going to perform some more advanced feature engineering part. So we will see that how we can create few more columns, and those will have a good impact on my final output. So after we have done the pre-processing with the text data, now the next step is again coming back to some feature engineering. Now, if you remember, I in last few lectures I was talking about that right now I am doing the basic feature engineering, but later I'm gonna again come back and do few more feature engineering, and which I'm gonna call it as advanced feature engineering. Now, in order to do that, I need to define few words here. So let me make it more clear. Like the first is token. Token means, let's say if I have word, right, present in my string 1, 2, W3, W4. If you split them, just like if you are coming from Java background, you might have heard about something called as string tokenizer, right? If you don't know about it, just ignore that up. So just like you are splitting it up into different tokens, split each word separately, that is basically called as a token. Okay, simple statement. Stop words we have already discussed a lot into our NLTK part. So it is, and, right, if, and so on. So all these words are called stop words. What is a word? Now word is also a token minus stop words. So like it is basically, word is nothing but a token only, but it is not going to include any sort of stop word like is, and, a, the. So these are the three things which is just to keep you informed, so that it makes our life easy once we go and derive some more sort of feature for it. Now let's understand the first two basically features which we are deriving here. Now the first is telling that it is the ratio of common word count to the minimum length of word count of Q1 and Q2. What does this mean? This means that whatever is the common word count. So let's say I have basically it's going to be for question 1 and question 2. I collect all the words and then I do take all of the basically I took the intersection of them. So I took all the common words being present in both the tokens. And basically then basically when I say this, I'm talking about word here, so I'm not basically considering the stop word. So then I just got all the words from it and then divided by, in Q1 what is the minimum length of the word, and in Q2 what is the minimum length of the word, right? So in this, basically whatever is going to be the minimum out of them, I'm going to just select that and divide it by this. So this is going to define my CWC underscore minimum, okay, which is common word count. You can call it as it is, common word count, and I'm getting the minimum. Similar way, I'm going to calculate or derive a new feature which is for the maximum part. So here again I'm going to take all the common word count. Again I'm going to look at all the common words between Q1 and Q2, and then I'm going to take the length of maximum of either Q1 words or Q2 words. Whichever length is going to be maximum, I'm going to divide it by that. So this talks about the first two derivation which we have just done. Now further to this, once we have done this, now if you look at the second part, which is CSC and CSC max. So in this case we are just going to look at the stop word. So it's called as common stop word count, okay. So in this case what we will do, we will look at the common stop words in between question 1 and question 2, divided by again the length of Q1 stop words or Q2 stop word, whichever is going to be minimum, we're gonna choose that. And similar thing we're gonna do it for the maximum. So we will just divide it with the maximum part to derive this particular column. Now let's also look at the third component out of it, which is your CTC. Now this basically means that common token. So if you remember, the first one was a word count which do not include the stop word. Now here we're going to look at the token part. So it is going to be common token word count. So here we will look at all the common tokens between them, which will also includes even your stop words, and then basically divide by minimum or maximum. So by this we will derive these 6 column. So this 6 column is what we got, and now further columns we will see to that. Now a question which can come to your mind, that how you even come up with this thought process that this is how you should do it. Again, this will come by practice. Now even I was not an expert while I was solving this problem. I would like to give all the due credit from where I also grabbed this idea. So I have gone through multiple research papers. I have gone through even the solutions what people have provided on GitHub, and I have looked at some top solutions which which were chosen to be the top solutions there, and from there I have seen that how those people were coming and deriving up all these particular columns and working on it. So this is how even I got all this insight. So you need not worry about that, how you can get that. So it will all come by practice slowly. Once you will kind of while solving these case studies itself, you will come across a lot of different scenarios which will make you learn a lot. So we will see a few more advanced features in further lectures. So let's look at few more derived columns here. So we have just seen that how to come up with the 6 values, which is common word count, common stop word count, common token count, right? So we have seen this part for min and max both. Now we're gonna derive few more columns like last word equal, which is just gonna check that if the last word in Q1 and Q2 questions are going to be similar or different. So it is going to return 1 if it is going to be similar, otherwise it's going to return basically 0. Now similarly we're going to check for first word also, where if the word in Q1 and Q2 question, which is the first word, is similar, we're going to return 1, otherwise going to be 0. Absolute length is going to be like, I have a length of my basically all the tokens present in the question 1, and I have the length of for question 2 also is available. So token again basically is going to be with the basically it's going to include even the stop word. So it's gonna be length of them, and I'm gonna calculate a difference of it. Now there's a possibility that maybe in Q1 I got, let's say, 50 words, and in Q2 I got 60 words. So I will do 50 minus 60, so I will get minus 10. So that's the reason we are going to return absolute value. That I'm only interested in getting the absolute difference and not basically whether it's going to be negative or positive. Then we do have a mean length, and as you can see, it's quite simple. We're gonna take the length of tokens of question 1 and token of question 2, and we are going to take sum of them up and divide by 2, so we will get the average of them. So this is going to be mean length. So by this time we have already seen somewhere around 10 different derived columns which we have just done. Now after this we go to a very interesting technique called as fuzzy ratio. Now this is very interesting, that, and in fact this is not something which is done by us at all. This is completely, even we grabbed the idea from various places, that how people have used this fuzzy ratio portion. So now if you go to this GitHub account, you can basically see the whole code being available for this fuzzy fuzzy. So this is basically fuzzy fuzzy. In fact, the name itself is very interesting, right? You can see that it's kind of a weird name what they've given. It's funny, in fact. So basically, you can install fuzzy fuzzy by just saying pip install fuzzy fuzzy, and this is just going to install at your end, because we're gonna use this package as well. Once you have done that, then this basically tells you a lot of examples also how to do that. But do not worry, I'm going to explain you that what exactly is this. Now if I go back, you can also see this. I've given you another link also, which is chair nerd. This is exactly coming from the same person who created all this GitHub account. So you can go to this, and there's a very nice written blog how to use this fuzzy fuzzy. Now the idea behind this fuzzy fuzzy is that given basically two questions, basically like Q1 and Q2, or two queries I should say, not questions here. So I would like to get the similarity between them. So the output of this similarity is always going to be between 0 to 100. Okay, now 0 means that the basically two strings are not at all similar, while 100 means the string is highly similar to each other. So that's what basically this similarity is going to tell me up. Now it works on a very interesting concept. Let me show you with some example here. It works on a very interesting concept of edit distance. So if you look at it, we do have something called as edit distance here. So this is a very interesting concept. So in edit distance, you can add a character, you can delete a character, you can shift a character. So like this, you can do some sort of operations on it. And the idea behind this string similarity is that basically here what we do, like for example, if you look at these two strings, New York Mets and New York Meets, though this is the name of two different teams, but still we just want to see how this edit distance works. So what edit distance means, that by just adding, deleting or shifting the word, can I derive from first string to another string? Like in this example, if you look carefully, in this example, if I can just add a character A, I will reach to this, right? So this means they are very similar. So this is how the edit distance works in this fuzzy fuzzy case. So in fuzzy fuzzy case, we just look at whether by adding or deleting or shifting some character, can I reach to my another string too. So now in this case, you can see that when I was calculating the fuzz ratio between these two strings, since they were very nearby, I got the value 96, which denotes that these two are almost very similar. I could have even given the same exact thing. If I would have given New York Mets and comma New York Mets only, I would have got the output as 100, because as I told you, 0 being the worst and 100 being the best. So this is how you do the fuzzy fuzzy part. Now we will explore this more in depth on fuzzy fuzzy, because even we do have some issue with this fuzzy ratio part, but we will do that in next lecture. So we understood about this fuzz ratio. So in fuzz ratio, we have discussed that we will look at the edit distance, and based on the edit distance, we gonna let the result that how many additions of character or deletion of character or shifting of character is going to bring up the final result, and based on that we were getting this result. But even this have some problem. The problem is, if you look at this part, like if I have a string, there are, let's say, two teams called as Yankees and New York Yankees. Now actually they are both the same team. Okay, so like for example, if I just say Royal Challengers Bangalore, if for people who watch IPL match in India, and or somebody say Challenger Bangalore, right? So something like that. So some people call it the Bangalore only, right? So people can call it just by short name or by the full name. So this is exactly same. So it should actually return you the total value 100, because these two are exactly similar. But what's going to happen here that we cannot do it, and in fact we're going to get 60 value here. Similarly, if we look at the first ratio for this, New York Nets and New York Yankees. Now these two teams are little different groups. Okay, so if you look at these two teams are different teams, New York Mets and New York Yankees. But still my fuzz ratio is coming out to be higher than even my Yankees versus this, right? So this is even higher in comparison to this, but it should have been the opposite way in fact. So now in this case, what we should do, so we have this problem of basically doing this. So we go for another way of handling this situation. So let me show you how to do this. So in this case, we go with something called as partial ratio. So in partial ratio, what happens is, if you look at this example, here we do have something called as Yankees and New York Yankees. So what it do, it looks at whether there is a string which is a substring of the other, complete substring of the other. So in this case, yes, Yankees is a complete substring of the other one. So in this case, it's going to return you 100. Now, if you look at the other example where we have New York Mets and New York Yankees. Now, in this case, this is not a complete substring of this. So that's the reason this output is going to be lower. Okay, so that's how this partial ratio is going to help you with this. But again, partial ratio also have a problem. So let's see that how to fix that. So first of all, let's see the problem. Let's see this example. If you look at this example in out of order, so basically just before I basically go and understand that, let's go back to this. So we have already discussed about these two matrices. Okay, fuzz ratio, where we saw that with respect to edit distance we can calculate our distance. Second is partial ratio, which looks at if there is any partial match of the string with the other. If it is a complete substring of the other, we call it as partial ratio gonna come to 100. And the third one now we're gonna discuss is called sort ratio. So let's see that what exactly is going to be this. Now, in order to understand this part, so for this we will go back to again over this. Now let's see. So here, what happened? Let's say if I have two strings like this. One is New York Mets versus Atlanta Braves. Okay, or we can say Atlanta Braves versus New York. They both are similar. Think about it like this. Like if somebody say India versus Pakistan, or somebody else say Pakistan versus India, right? Now, if these two strings, if you look at, they are exactly same. But if you go and basically try to find out their fuzz ratio or partial ratio, you will notice a less value to it. It's not going to return you basically the exact value what you can expect here. So you can see that we are getting 45 and 45, which is quite low. But this should actually return us 100. Now, in order to handle this, we take something called as token ratio. So what token ratio do is, it is going to first sort all the tokens and return it, and then gonna do a comparison. So when it is going to do that, you're gonna get all fully 100 result. You can see that here we are getting 100 result, because what it's gonna do, it's gonna return, you can see here in this example, like this string is first converted to your sorted string, and then when we apply the sorted ratio, we got the value as 100. So this is how we can go back and always look at the sorted ratio. But again, this also have a problem. That's the reason we have the fourth one. We will discuss that in the next lecture. Okay, so we have gone till token sort, and we have solved multiple problems till token sort. Now what we're gonna do is we're gonna look at the important factors. Like there is still some issues with this. Like for example, if you look at this token set, you can see here that in this particular example we do have like marine and angels, and here also we do have angels, marine, but there are a lot of other words which are also there. Now in this particular case, if we try to look at the sorted word, it may not work. So what we do is we take a little different approach to get a good output. So what we do is we basically if we apply the token sort here first. So let me apply a token sort. Now we got to this stage where everything is sorted right now. Now there is a typo here, so you can see Angel versus this part, but here there is a versus extra coming up, but there is no versus in this T2 S2 string. Sorry, so there is nothing extra here. So this is a wrong maybe typo in this block. Now further to this, we take a different strategy. Here what we do is we take T0 where we take all the sorted intersection. What is my sorted intersection in this case? I have Marine and Angel. These two are common words, right? Only these two. So this is going to be my sorted intersection. In T1 I have sorted intersection plus the words which is left out in string 1. So it's going to have Marine versus Angels, 3 words. T2 will have sorted intersection plus all the words which is left out in this. So let's see what basically we have done till here. So if I come down and see this result now, so you can see that this is my T0, T1, T2, and when I found basically when you look at it, how we got this up. So first this T0 is nothing but the common word. The T1 have common words plus remaining words in your string 1. So T2 also have common words plus the remaining words in your T2. And then after that, what we do is, as a next step, we're gonna calculate the fuzz ratio of this. So we get, let's say 90, 96, 50. And then when we apply the set ratio, we got the maximum one, which is 90 in this case. This is how you get basically your set basically ratio for your token. So this is interesting, and you can see here that we can get the best result, but there are some problem with set ratio also. You can see that we have like two string like Sirhan and Sirhan. So in this case, it will return you 100 because it looked at a set of the value. So even though it's common, it doesn't matter to it. So these are the problems with it. I strongly recommend you to please go back and read this particular block. This is very nicely one of the best written block which I have seen. In fact, if you try to read any of the textbook, or if you have gone through any of the machine learning courses, you will never ever kind of come across in the courses about these things. But we have learned this particularly as a part of this case study. But this knowledge, you can keep it with yourself for the lifetime, because this is going to be really helpful for you wherever you are kind of trying to solve a problem, wherever your problem is kind of document similarity. If you are finding the similarity between two documents, it is going to be very, very helpful in those cases. So I would strongly recommend you to kind of walk through the whole block. I have given you the insight, but if you go through it on your own, you will get even a better clarity of how to do it. So we just understood what is fuzz ratio, what is fuzz partial ratio, what is token sort ratio, and what is token set ratio. And one of the very interesting thing about this is that you can also go and look at the source code what is written for this. So GitHub profile is already provided to you here. So you can, at any moment, you can go and look at the source code of this particular stuff, which makes it more interesting. In fact, I would strongly suggest you to please look at it so that you can get an idea that how people are coming up with such a unique and interesting ideas to solve these kind of problems. So I would strongly recommend you to please go through it and check this particular stuff. Now we do have one more stuff, which is longest substring ratio. What is this? So first of all, let's understand what is this longest substring. So when I say longest substring, what I mean by that is basically, let's say if I have two string like this, C1, C2, C3, C4, C6, C2, and so on. Let's say this is my string. And let's say I have another string which is C2, C3, C4, C6, C5, C9. So in this case, if you look at it, we do have a longest common string. If I have to catch, this is going to be longest matching string, right? Which is what? Which means the common string, that's the one thing. But what is the maximum length common string? So even these two are common string, but the length of this common string is 2. So I am looking for a common string which is at the maximum length. Okay, so this is called as the common string. In fact, if you are coming from the computer science background, in your algorithmic courses, you must have read about these algorithms a lot, right? Where you have whole chapter basically dedicated for this. Now, so this is about what's to find the longest substring, and what we wanted to do as this column is we want to get the length of this longest common substring divided by the basically length of Q1 token and length of Q2 token. So whichever is minimum between two, I'm going to take basically the length of it and going to return it. So now with this, we have got so many derived advanced columns. So if you look at it from starting, we have six first records which we got for common word count, common token count, common stop word count. So there were six with respect to this. Then we looked at these four more, which is basically for your last word equal to first word matching. What is the length between difference of length between those tokens, and also we have figured out the average length for it. Then we looked at a very interesting concept of fuzzy wuzzy, where we got the four new values for fuzz ratio, fuzz partial ratio, fuzz sort ratio, and token sort ratio. And then we also looked at the longest substring ratio. This is basically one more extra part which we have just seen. So we got almost how much? 6 here, 4 here, which is 10, 4 for fuzzy token, which is 14, and 1 this. So 15 columns which we have derived. We'll see that how to use them up now. Okay, so by now we have calculated a lot of advanced features along with the basic features. Now what we're going to do, we are going to take up some more work with respect to creating all this, right? So we need to write a function for this, and writing these functions is quite simple, right? So if you take a look at this, we have basically passing these two questions, we are calculating all the features, like you can see that we are also giving the name for this, like CWC min and so on, right? So these are the features we are creating. Even if you look at your fuzz ratio and all that, you can see that we are basically calling token sort ratio, token sort ratio, and so on. So again, these are all the things which we have even discussed. It's just that we are going to put everything into programmatic feature. So we have created almost 15 features by now using this particular portion. Now once we are done, we can see all this output. So you can see it here that what all the features we have just created after creating that fuzzy ratio. So further to this, let's do some analysis just to understand that how it's gonna look like. Now what we're gonna do, we're gonna look at a word cloud. What is a word cloud? Word cloud is going to look something like this. What does this mean? So this is a word cloud for all duplicate question. So what this word cloud is doing is it is showing you all the words which are very commonly occurring into your duplicate question. So these are the words which are continuously occurring into your duplicate questions, like Donald Trump, difference, 1k, rupee, best way. Similarly, I want to see for the non-duplicate words, and these are the words like India, not, will, one, difference. So these are the words which are basically not very frequently occurring into a non-duplicate questions. Now, once we are done with this, this is just to give us some insight that, okay, what kind of words, if we see that most likely it's going to be my algorithm is going to learn from it that, okay, if these words are there, most likely it's going to be kind of repeating question or a non-repeating question. Now further to this, we have created a lot of features, advanced features. So what we're going to do is now we're gonna put all those features basically here and do some analysis. So what we're gonna do is creating a pair plot on CTC min, CWC min, CSC min, and token sort ratio. So I have created for these, but feel free to create for more. Okay. The reason we have not created for more because actually we have tried that and they were not looking that great. So the features which were making sense were this while doing the pair plot. So you can see here that it's showing a very nice distribution, right? So if you look at this particular graph, there are some of the places where we are getting a very nicely separated one, like you can see here. So here we can very easily say that in CSC min, and if we compare the first column, which is CTC min, so we can very easily write an if else loop and separate them out, right? And you can see not only in this one graph, but in fact in most of the graphs you can see that there is a very nice distribution happening basically, right? Even in this, right, there may be some mix up here and there, like in this. So there is a very nice kind of distribution which is happening, which means that these columns are highly important for our analysis. Now, once we are done with this, let's do some more analysis just to see the distribution. And you can see here that when we created this graph for token sort ratio, you can see here that we do have again a very good distribution of graph in terms of, you can see that this is not exactly overlapping. This is basically there is some overlap but not fully overlap. So we are getting a graph something like this. So it's okay. Basically, we can still see that when my token sort ratio is going on the higher end, then basically my duplicate questions are going to increase, right? So this is what we are getting an idea. And if my token sort ratio is on the lower end, then it's going to be kind of my we can see that we have non-duplicate questions. Similarly, we can look at these histograms. We can plot an histogram with this, and you can see that yes, even in histograms we do have a good difference. Like if you look at the median values for both, they have a very distinct highly apart from each other. So we are basically looking at a duplicate portion. So this again reflects that we are going in the right direction, and these columns are highly important. Let's do the same thing for the fuzz ratio, and for the fuzz ratio exactly the same thing. What we can notice, there's an overlap, and we can see for the higher value of fuzz ratio we do have again in this case some duplicate values. Now let's do some visualization. When I say visualization, what we're going to do is this is 15 dimensional data, right? So definitely we do have even some basic additional feature which we have added earlier, but let's say if I only consider this 15 advanced feature which we have created, so what we're going to do is definitely it's impossible for me to visualize that 15 dimensional data. So what I'm going to do is I'm going to take up and reduce it to maybe 2 dimension or 3 dimension and see that whether we are going to still make some sense out of it. So here we are going to take up only 5000 rows, because TSNE will not be able to take up so much of data, again as we learned in the TSNE kind of topics. So here we are keeping the method as Barnes said, we are taking iteration as 1000, we are going with respect to components as 2, and basically if you look at this, we have basically computed and converted to 2, and we are basically also kind of plotting this up. So when we are plotting this up, you can see that this is the output. So this is a nice distribution, right? We have converted 15 dimension to 2 dimension, but we can still see that we have a very nicely separated data, like at least in this region, this region is very nicely separated. Here also we have a very good separation. Here also we do, yeah, there is a small mix up, that's definitely there, but still it's a very good kind of visualization we can do in 2D itself. Now this is telling us very clearly that we do have this model have a very nice sense basically for this. So this is basically telling us that yes, this model is whatever 15 features we have created, they are highly important. So that's also one thing what we get from it. Now again we can do the same thing with let's say 3 dimension, and let's see with 3 dimensions we can also plot a scatter 3D plot, which you might have learned in a machine learning course, that we can also visualize it in a 3D way. This looks more cooler. Let me show you. In fact, you can like move this, even if you want you can kind of zoom, kind of look at the data. You can even kind of keep moving and keep scrolling. So this you can visualize it basically in a 3D format. Okay, so this is a nice box which you are noticing here, which you can visualize it, and very nicely if you hover over it, it will also tell you the points. So again, for us the crux point here is that we can easily visualize by just looking at this data, and that means that all our features which we have created are highly critical, and we're gonna use it for our further analysis when we're gonna apply our model on top of it. So now we are going to apply some featuring on text data with weighted TF-IDF word vector. So remember we discussed about basically this is a part of NLP which basically comes across TF-IDF and weighted word vector, right? So this is more advanced technique in NLP you must have learned. Now basically in this TF-IDF weighted word to word vector, what we gonna do is so there are various ways to do this, but there are a lot of packages being available to you for doing this. So one which basically I have found is very interesting, which is Spacey package. And in this we have something called as glom. Okay, so this is gonna return basically weighted word to vector tf. That's basically what it's going to return for me. Now, the way it is done, the code is very simple. We will just use the data train.csv, and you can see that even I have properly put all the comments that from where it is being taken up. It is taken up from Stack Overflow, some idea how to convert it to str and all that. So this code is taken up. So this is question 1, question 2 is duplicate, and we gonna do some feature engineering and gonna convert to it. So you can see that I'm using this tf-idf vectorizer, transforming it up, creating a dictionary, and using this spacey load. Once you have imported this part, you can just load it up. In fact, this is very strong. And installing it's very simple. You can just say pip install glove and it's basically take care. So I have done a typo there. It's not glom, it's glove. And basically here it is trained on Wikipedia, so it also kind of takes care of word semantics, which is much more powerful case here. Now, once you have done this, then you gonna apply it on question 1 and question 2. So let me give you an intuition that what we are trying to do. So do you remember we do have some simple features? So one part we have is simple features, what we do have earlier. Now the second part was we have 15 features which we have created. So those 15 features I need to add it extra here. Then further to this we had basically the TF word to vec, weighted word to vec for question 1. So this is going to be your TF, basically TF word to vec, which is weighted basically, and this is for question number 2. Okay, this is for question number 2. So this is what will be a final data frame which gonna come up, and then in the last we're gonna have a column which is going to be is duplicate, right? So now you can see that this will become like a proper classification problem for us, which we can work further. So this is what being done in further code. So understanding this code is quite simple. Now you can see that we are just applying in question 1 and walk through it. Similarly, we're going to apply in question 2. We will get 2 columns. So earlier we have all the separated columns. Then after that, you will notice that so you can see that this is for question 2. Earlier one was question 1. And then you can just basically merge all these things together and create a data frame, which I explained. My strong suggestion, though I'm just explaining you the main insight of it, but please walk through each and every line of the code. Try to write it up. It's quite simple. The reason I'm not doing it because my focus is to explain you the project, not basically line by line. So my assumption is that through machine learning courses or through NLP courses, you know all these things up. So again, the intention will be completely on project. That's the reason I'm not going line by line. But you have to walk through each and every line and see if you want to change something. Maybe my code, you can just write something better than my code. So please do follow all that. So now we're gonna start building our machine learning model. So again, we have loaded all the package required, and now we're gonna load the data again back. Only difference this time is, so remember this was my final feature. So only difference this time is I'm gonna use the SQLite DB to put it. Now, SQLite is the most lightweighted DB what we have. In fact, in your Android phone, in your iPhone, in basically this is very lightweighted, so it's being basically installed along with it. So now this data we are going to convert it. So also the advantage of using SQLite is that you can also write your SQL query in this case. So your SQL query will also work. I will show you an example with it. So what we have done is we basically loaded this data into my SQLite DB. That's what basically we are doing in this case. Now, if you want to go and read some more of the tutorial, you can always go and read it from here. Now, this is to create the connection. Okay, so this is to help you to create the connection with SQLite, and this is going to check whether the SQLite, basically the table exists or not, right? So that's what it's gonna do. Now we're gonna just create the connection, check the table exists or not, and then work on this. So then after that, you can notice that what we are also doing is we are taking the data and we are limiting it only 10,001 records. So we are not going for lot many data. We are just taking 1 million rows so that we can perform these operations on our basically laptop. So even if you have 4 GB of RAM, you should be able to do it. Otherwise, you may end up with issue, but feel free to use even the whole data if you have no issue with RAMs and all that. Now once you're done, then further to that you can also basically drop the indexes whatever you don't need, the first row especially, and this is the data what you have. Now what basically we have, if you recall, we have the advanced features, we have the simple features, we have word to vec for question 1, word to vec for question 2, that to TDIF for weighted one, and then we have the final column. So now let's convert the string column to numeric column. So if you recall, these were all my data, but we are just converting whichever is categorical, we are converting to numerical. And you can see it here that these initial one, what you're seeing, fuzz ratio and all that, and CWC min, these were your advanced features. Then you can also see that these frequency and all these were your simple features, and these basically are coming out as, this is for question 1 TDIF. So you can see that it's running from 0 to 383, I believe. Let's go and check. So if we keep coming down, you would notice that this will be having somewhere around 383, right? So 0 to 383. So means it have created 384 columns for it. And similarly for question 2 also, it will have the similar number of columns here. Now once this is done, we basically are going to take up the split train test split with 70-30%. That's the simple code written for the same. Once that is done, we can just look at the distribution of the columns data. So for class 1 for the train data, what is the distribution looks like. Then further to this is a simple code. We have seen it even in the last project of medical treatment, that how to create the confusion matrix. So it is gonna create a confusion matrix and precision and recall matrix for you. That's what is being done here. Now let's build a random model, and if you recall from the medical treatment project, we have done exactly same there, because here also the metric required is log loss. And if you recall from the medical treatment project, what we have done there was the log loss can move from 0 to infinity. Now because of this, I don't know if the model which I have, how to compare whether it's a good log loss or bad log loss. So what we will do, we will create a log loss for the random model. Now let's say it comes out to be 0.9. So now my any model which is better than random model should have log loss lesser than 0.9. So the more it is closer to 0, it is better. The more it is near to 0.9, it is a bad model. So that's the same concept we are going to use here. So we are going to create a random model here on the same, and you can notice that it is giving the confusion matrix, which is telling me that basically this is the original class, this is the predicted class. So 9482 are correctly classified in 1, and 45433 are correctly classified in 2, but the remaining all this diagonal part are wrong, like 9493 is a wrong one, similarly 5592 is a wrong one, and that's expected. It's basically random model, so we cannot even expect that it's going to give me a good log loss. And similarly, confusion matrix log loss also, you can notice that on test data we are getting around 0.88. Now definitely whatever model we are going to create, that should have a better log loss than this to be adopted. Similarly, you can look at the precision recall, and they are also not sounding that great, and that's obvious because again we do have basically precision recall are generated on the random model, and it's not even expected to have a better value. So this is all about how you can perform on this. And at the same time, as I was telling you, so definitely for solving this project, it's better if you have already solved the medical treatment project, because I have already explained a lot of things there which I'm skipping in this case. So I have explained a lot of concepts from, so I'm just assuming that you have already completed. If not, you can please follow that as well, because that have a lot of beginner explanation in case if you have not covered it from your normal machine learning course, then basically you would have learned it from that project. So I have basically covered what is log loss and so on, and why we are creating random model in detail in that particular project. So please do follow that. So this is how we have generated the random model. Now further to this, we will create some logistic regressions, linear SVM and XGBoost, and we will see that which will give us a better log loss in comparison to this. So we will do that from next lecture. So what we have done last time was we created a random model and we got the log loss around 0.88. So with a random model we have 0.88. Now what we are going to do in this section is that we are going to create different other models, and in fact what I would be working on is mainly logistic regression, linear SVM and XGBoost. Why not other like random forest? Because remember, this is a huge dimensional data. We do have like almost 790 columns, which is huge. So the other algorithms may not work well, but I leave it as a homework activity again for you to basically apply them up and see if you may get a better result. Let me also know. But most likely this is not going to work well, so and it will also take a lot of time. So that's the reason we are sticking towards techniques which towards algorithm which basically are going to work well with higher dimensional data. So let's start with logistic regression, and here we are also kind of doing a lot of hyperparameter tuning. Now you can see that we have put a lot of comments for understanding all this part, and here we are going to choose an alpha. So this is going to be an hyperparameter. So we're gonna take multiple values of alpha and gonna run our algorithm. So you can notice that I'm using a log loss of log, which means that I'm using a logistic regression. Secondly, I'm using the L2 regularizer, and basically I'm running it for all the alpha values of I. Right. So now when I'm going to run it, remember it's a log loss, and we have learned that if whenever you have to work on log loss, it is always you have to use calibrated classifier so that you can convert anything to a probabilistic format, because remember log loss always require probability. So we are going to use it. We're going to fit the model, predict the probabilities, and this is what we have done for it. Now if you notice, my log loss is coming minimal for this value, which is with 1, and we have also plotted it up. And if you notice, this code is very similar to what we have seen in medical treatment also. There is nothing too special about it. So now you can see that with this graph also, that at the value 1, this is kind of at the minimum part. So now what we will do, we will look at the log loss at the train and the test, and you can notice that both this log loss is coming quite close, which means they are not overfitting. So they are not overfitting. This is what we are. But can I really say this for underfitting? No. Now, if you look at it, we got almost like 0.52. Now, ideally, I should have got near to 0, and this was my random log loss, and I have come somewhere around 0.52. This is not great number, right? I could have come somewhere around 0.3, which would have been far better than this. So since I'm getting around 0.52, there is a chance that maybe my logistic regression might be underfitting, and that's the reason this is giving me this part. Remember, logistic regression have a problem of bias. So you can go with high bias if you are using logistic regression, and that's the reason we have to look at this thing. So what we will do, we got logistic regression which is taking us to 0.52. Let's see if we can get a better number with SVM. But before that, I want you to also notice one more interesting fact here. If you look at the precision and recall, definitely my precision is looking okay, not a big issue. But if I look at my recall, there is a big problem. So this is fine, but this is not fine. Because if you look at it, I am misclassifying almost like 50% of my point, which is definitely a big no-no for me, right? Big no-no for me, because this is a big huge concern. More than 50% of the data we are misclassifying here for class 2. For class 1 we are very good, means definitely this is a very good number, I would say. But the second part is definitely basically a big concern for me. So let's see if my linear SVM is going to help me solving this problem. Now again, we're going to apply linear SVM for the hyperparameter tuning. Now same thing, we gonna apply the calibrated classifier. You can see that I'm using this time the penalty as L1, not L2. I'm using the hinge loss, but feel free to change it to L2 and see that what's gonna happen. Now after that, you will again do exactly the same code, and this time your log loss is coming minimal here, 0.48, right? And if you even try to infer it from the graph, it looks the same, right? Now let's look at the log loss values. So now we got to this number. This is better than last time, but definitely this is also telling me that we are not overfitting here as well, right? So this looks good. So this is not overfitting. Now let's note down this number here also. So with linear SVM, we are coming to 0.42, right? 0.48, sorry, 0.48. Not a great improvement, but okay. So again, we can notice that there is a chance of overfitting even here, because this is not a great number what we are also getting. Now let's look at the precision and recall. Maybe is that improving for us? Then maybe we can say that, okay, fine, we can still be okay with this model, but we have to first go and see that. Now here, when you see this number, again, we have so many of the misclassification. This is awesome, even working better than your linear SVM, but this is a big concern. Okay, so again, my linear SVM also have a chance of bias, so this can also be an issue for us. Now what is the next solution? Next solution is looking at XGBoost. Let's try that. Now here I have not done much of the hyperparameter tuning. I would like to leave it to you to do that, hyperparameter tuning. So I am having all these values, max depth and everything, and we are passing all these values, creating the matrix, and we are calculating the log loss after training all the model with XGBoost. I need not explain this code because you are quite familiar with XGBoost by now. So you can also write it in a different way, which I have shown you in the class as well of machine learning course, but feel free to use it in whatever way you want. I've just keep on playing with different syntax here and there. Now, if I look at my basically these values, so what is the output? So definitely this is doing a lot of iterations, and remember 790 is an okay data set for XGBoost. Maybe if you have 10,000 columns, then XGBoost may not work well. So keep that in mind. And XGBoost also have a big problem that it can overfit a lot of times. Okay, so you have to be little cautious with XGBoost at that point. Look at my log loss. 0.3435, and the training loss was 0.34. Look at this number. This is a wow for me. So this is the part, and this is my test log loss, right? So looks like this is also not overfitting, which is quite good, right? Because XGBoost have a high chance of overfitting, but looks like this is not overfitting. Secondly, this number is now coming to 0.34, and remember, I told you this point. If we would have come somewhere close to this, we could have said that it's a good model, because now it is quite far from 0.88. On the other hand, any number close to 0.5, I cannot really say that it's too good from the random model. So now this XGBoost is definitely working better in comparison to last one, but definitely remember, we have to look at the precision recall also to basically make sure that we are not doing wrong. This is okay. Now this is not 0.5. This is 0.3, which is okay. So looks like we have improved, and this is still excellent. So we have now improved and got this particular solution, and now we can say that in this case we can particularly choose XGBoost to basically build this model. Now I would say that please go ahead and build with other classification algorithms what you are aware of, and see that whether they really give you a better result than this. I have already done a lot of experimentation on this code, and trust me, they are not going to work better. But still, I would like to see if you can come up with something interesting. Means except neural network. I'm not going with neural networks because that is not being taught yet. This will be a deep learning topic. But whatever you have learned from basically from the knowledge perspective of basically for you for machine learning, then I would like you to apply. So this is the solution for Cura project.